All right. So now let me share my screen again, and I think everything should be okay now. All right. So we have 44% of you saying it is machine language, and we have 33% saying it is object code. 11% are saying it is source code, and we have 11% saying A and B. So yesterday we learned that machine code is also known as machine language. At the same time, it is also known as object code. So in programming, when you hear object code, we are talking about machine code. It's also the same as machine language. It is not source code. So the correct answer is D. The 11% who selected D, you are right. Now, when you get an examination question, you need to look through all the answers before you select your own. So we have 44% saying machine language. You are right, but B is also right. So the correct answer here is D. Let me take you through the next question. It says that which of the following best explains the English word include? So here I'm taking you through English language, and it says that which of the following best explains the English word include? We have A, add. We have B, insert. We have C, ignore. And we have D, A and B. All right, so this is just English. It is just English. So which of the following best explains the English word include? When we say include, what does it mean? Does it mean to add? Does it mean to insert? Does it mean to ignore? Or A and B? Please submit your answers now and let's see. All right, so make sure you submit your answers and let's do this. All right, all right, all right. That's wonderful. Okay, so we can see the answers coming in. Some are saying it's add, some are saying it is add and insert. Some do not know what to say, and it's all good. So let me take you through my slides and show you what we will be doing today. Today, I'm welcoming you to C++. I'm welcoming you to C++ itself. And so I'm taking you through the language, and we are talking about C++ itself now. Yesterday, we learned about translators, and we learned about the CIA of translators. C stands for compiler, I stands for interpreter, and A stands for assembler. So these are the three translators we have, and they are all used to translate high-level source code as well as assembly source code into low-level machine code. We learned that translator is a programming language processor that converts source code into machine code. So source code is also, machine code is also known as object code. It converts source code to object code. Now, any code written in a high-level language is known as source code. All right, so C++ code is called source code, and we also have machine code, object code. All right. Today, I want you to type this line for me in the chat. Type std : cout. We did this yesterday, so just type this for me, std : cout, and this is going to prepare you to know how to code very well. So just type this in the chat. Go through the chat and just type this line. Don't worry about it, just type it. Look at it carefully. Don't make any mistake. Just type this in the chat and submit. If your chat is not working, go to WhatsApp and post it on WhatsApp. If WhatsApp is not working, go wherever you like and post it. Let the whole world know that you are learning programming. All right, let's check the answers again and see. So we have 36% saying to include means to add. Okay, it makes a lot of sense. It makes a lot of sense because when you add, you are actually including. How about insert? Okay, so when you To include means to add because do a lot of hash include in C++. And with the hash include, we are actually going to include a lot of C++ header files. One thing we need to understand is that when it comes to coding, sometimes we do what we call reusing code. I want to repeat that. Reusing code. There are some codes, we reuse them. Now, codes that you reuse, the best way to handle code reusing is for you to actually write the code once, store the code somewhere, and insert the code into any program you want. For example, the IO stream we've been hearing about all the time. It is actually a code. Tomorrow you know all about the IO stream. It is a code somewhere, and it is needed for almost every C++ program. And so instead of creating that code every time for your program, we have actually created it and stored it somewhere. So when you are starting any C++ program, all you do is to insert it into your program. Once you insert it, it comes within your program and it activates the features you want. Without including it or adding it, you would have to type it or code it yourself. And so for the purpose of reusing code, we will write important code once, codes that we can reuse once, and we will include them. So this concept, we are going to deal with it all the time. So the correct answer is D, and 55% of you got it right. Now let me check your chats and what you are submitting. And let me see, most of you are doing it. Well done, well done, well done, well done. You are doing well. This will help you become a good programmer. All right. Now, did you know that this lady right here was the first computer programmer in the whole world? This lady here was the first programmer in the world. And so it says that the first computer programmer was a female. Did you know that the first computer programmer was a female? The first computer programmer was a female. Her name is Ada Lovelace. Ada Lovelace. Her name is Ada Lovelace. Ada Lovelace. And Ada Lovelace was the daughter of the English poet Lord Byron. And she is considered to be the first computer programmer. In the year 1843, she worked with Charles Babbage. I'm sure you've heard of Charles Babbage. If you've done generations of computing and the history of computers, you have definitely heard of Charles Babbage, because Charles Babbage is considered the father of today's computer. He manufactured the computer we call the difference engine and the analytical engine. And that model, that design, is what has been improved upon to give us today's computers. So Charles Babbage is one of the most important personnel in history when it comes to computer history. So Ada Lovelace actually worked with Charles Babbage, and she actually created a software for one of his computers. So the inventor of some of the early mechanical computers, Charles Babbage, Ada Lovelace created the first program for one of his machines, the analytical engine. So the analytical engine got its first program from this lady, Ada Lovelace, and from that time, her name has gone into history as the first computer programmer. And she did programming for Charles Babbage. Anytime I'm teaching my students and we come across Charles Babbage, I tell them again that the name is not Charles Cabbage, it is Charles Babbage. All right, let's move on. This is myself, your humble servant. My name is Darlington Fadams, and I'm your instructor for this C++ program. Today's motivational quote: all our dreams can come true if we have the courage to pursue them. Wow. All our dreams can come true if we have the courage to pursue them. So if you can pursue your dreams, it will come true. What you have in your heart to do, if you can just pursue it. Sometimes you have dreams in your heart, but to take the first step will take you years. It will take you years. Sometimes you don't know why you are not starting. Sometimes you are just afraid of failure. Sometimes you think you need. Sometimes you think you are not qualified enough. But I want to promise you that if you can pursue your dreams will come true. Some of you want financial independence. You want to do your own work. You want a business that will let you become your own boss and give you a good stream of income that you'll be independent. But to take the step, you don't know what to do, and you are just waiting and waiting. Someone wants to start a YouTube channel because he believes that if he's able to grow the YouTube channel, he will be able to get all the money he needs. And it's true. But to take the first step to record the first video, the person is just there waiting and waiting and waiting, giving excuses upon excuses. So just pursue your dream, take the first step, and your dreams will come true. All right, today's lesson, I want to welcome you to C++ itself. We are delving into C++, and we are going to learn the language. What is C++? C++ is a cross-platform programming language that can be used to create high-performance applications such as games, operating systems, device drivers, office applications, web applications, desktop and mobile applications. Today, we are starting our journey into C++, and we learned that C++ is a cross-platform application programming language. And what it means is that it can be used to create applications for iOS, for Android, for Windows. It can be used to create applications for desktop, web, and mobile. Why should you learn C++? You have to learn C++ because C++ is one of the world's most popular programming languages. Most popular applications were developed with C++. Most companies rely on C++ applications. C++ is a high-ranking cross-platform programming language, and C++ is fun and easy to learn. If you really understood the importance of C++, I think you will really take this seriously and learn it, because this is what will make you a programmer. If you want to be a software engineer, this is what you need. After this, we'll learn Java and Python, and you will be everything you are hoping for. What are some of the real-world applications created with C++? Did you know that Google Chrome was developed with C++? Google Chrome that you use every day, it was actually developed with C++. Did you know that Adobe Photoshop was created in C++? Wow. Someone used C++ to create Photoshop. I read about the history of Photoshop, and Photoshop was created by one person called Thomas Knoll. Thomas, Knoll, Thomas Knoll. He has a brother who is a PhD student, also computer scientist, and his brother John Knoll came to meet him one day creating this program. When he tested it, he realized that this program is wow. So what they did was that they found a company that sells scanners, and they actually partnered with that company, and they released the first version of their program. At that time, it was not called Photoshop. So they released the first version, and they added it to the scanner. So they put the software on the CD so that when people scan documents, they will use that software to edit the document. Later, they understood that this program can do more, so they started looking for investors. And so John Noll went to Silicon Valley, and he went to do a presentation to Apple and to Adobe. Actually, he was doing the presentation to Apple, but the marketing manager of Adobe was there in that meeting, and he heard everything going on, and they set up a meeting, and that was when they bought a license for Photoshop. And from that day, Thomas Noll, John Noll have been working with Adobe, and they released Adobe Photoshop version 1.0. Before then, we already had some versions in the market that people were using. But after they rebranded, they released Adobe Photoshop 1.0. And today we have Adobe Photoshop CC 2019 and more later versions. If you open to Photoshop, you are going to see Thomas Noll pop up in the splash screen. You are going to see John Noll, and it's wonderful. Adobe Illustrator was created in C++. Adobe Acrobat Reader, C++. Did you know that Excel was made in C++? Access, PowerPoint, Microsoft Word was created with C++. That's wonderful. This is the man behind C++, and today I want to introduce you to the man, the brains behind C++. This man actually looked at this language, and he decided to bring out the vision he had. He was an advanced software engineer in the 80s, and at that time, there was a powerful programming language called C. C was fast, C was efficient, C was low level enough, even though it's a high level language, it was low level enough to be used to develop operating systems. And did you know that Windows was created in C? Linux was created in C? Mac OS was created in C. But then this man here, I'll mention his name soon, he realized that C didn't have object-oriented programming features. There was another language called Simula. Simula had the object-oriented programming, but C didn't have. But C was amazing in its own way. Simula was also amazing in its own way. And so what this man did was to integrate Simula with C and made C++ out of it. When he finished, he didn't know how to call it, and so he called it C with object. And later, they renamed it as C++. His name is Bijan Stroustrup. Bijan Stroustrup. You can say Bijan Stroustrup is the same. So Bijan Stroustrup, born December 30, 1950. Right now, he's 71 years old. He's alive right now. He's a Danish computer scientist, most notable for the invention and development of the C++ programming language. As a visiting branch. The introduction you to him, and you'll be amazed. In the morning class, when I introduced to the class, I actually played a video of him when, okay, so in that video, they were asking him to tell why he created C++. And I want to try and get that video for you to also listen to him, why he created C++. And then we will listen to another video that tells us, we'll watch another video, and he's going to tell us why, or he's going to tell us the 5 most important programming languages to learn. So let me just open this.
My name is
this phone.
I'm from Nigeria. I'm a
And
real-time control.
All right, so I'm going to let you watch this.
In the really old days, people had to write their code directly to work on the hardware. They wrote load and store instructions to get stuff in and out of memory, and they played about with bits and bytes and stuff. You could do pretty good work with that, but it was very specialized. Then they figured out that you could build languages fit for humans for specific areas. Like they built Fortran for engineers and scientists, and they built COBOL for businessmen. And then in the mid-60s, a bunch of Norwegians, mostly Ole Johan Dahl.
All right, so they are just asking him why he created C++. And so this is a man, he's alive right now. This is how he's looking now. And he's telling us why he created C++. So let's just watch this.
Thought, why can't we get a language that sort of is fit for humans for all domains, not just linear algebra and business? And they built something called Simula. And that's where they introduced the class as the thing you have in the program to represent a concept in your application world. So if you're a mathematician, the matrix will become a class. If you're a businessman, a personnel record might become a class. In telecommunications, a dial buffer might become a class. You can represent just about anything as a class. And they went a little bit further and represented relationships between classes. Any hierarchical relationship could be done as a bunch of classes. So you could say that things, humans could get it. With low-level stuff, which at that time was the best language for that was C, which was done at Bell Labs by Dennis Ritchie. And take those two ideas and bring them together so that you could do high-level abstraction, but efficiently enough and close enough to the hardware for really demanding computing tasks. And so C++ has classes like Simula, but they run as fast as C code. So the combination becomes very useful.
All right, so he combines
Simula. If I have to characterize C++'s strength, it comes from the ability to have abstractions and have them so efficient that you can afford it in infrastructure. And you can access hardware directly, as you often have to do with operating systems, with real-time control, things like cell phones. And so the combination gives something that is good for infrastructure is stability. When you build an infrastructure, it could be sort of the lowest level of IBM mainframes talking to the hardware for the higher level of software, which is the place they use C++, or a fuel injector for a large marine diesel engine, or a browser. It has to be stable for a decade or so, because you can't afford to fiddle with the stuff all the time. You can't afford to rewrite it. I mean, taking one of those ships into harbor costs a lot of money. And so you need a language that's not just good at what it's doing. You have to be able to rely on it being available for decades on a variety of different hardwares, and to be used by programmers over a decade or two at least. C++ is now about 3 decades old. And if that's not the case, you have to rewrite your code all the time. And that happens primarily with experimental languages and with proprietary commercial languages that changed to finish fads, to meet fads. C++'s problem is the complexity, partly because we haven't been able to clean it up. There's still code written in the 80s that are running, and people don't like their running codes to break. It could cost them millions or more.
All right. So in this video, he talked about why he created C++, and he said at the time they had C, and C was amazing, but then C didn't have classes. And so they wanted a program that can combine the works of C with object-oriented classes. So there was one program or one language that was created called Similar. So what he did was that he combined the features of Similar with C and came up with what we call C++. All right, and he said C++ is a language that can run on multiple platforms, multiple hardware, and it's a language that once you write your code in, it can last for decades. And so this is why C++ is still around, because most of the very important programs we know came out of it, and they are still running today. I want us to watch one last video for 2 minutes, and he'll tell us about the 5 most important programming languages to learn as far as he is concerned. So let's listen to Björn Strastrup, and we will know.
First of all, nobody should call himself a professional if they knew only one language. And 5 is a good number for languages to know reasonably well. And then you'll know a bunch just because you're interested, because you read about them, because you wrote a couple of little programs for experimentation. But 5 isn't a bad number, somewhere between 3 and 7. Let's see, sort of my list is going to be sort of uninteresting because it's going to be the list of languages that are best known and useful, I'm afraid. Let's see, C++, of course, Java, maybe Python for mainline work. And if you know those, you can't help know sort of a little bit about Ruby and JavaScript. You can't help knowing C, because that's the fills out the domain, and of course C#. But again, these languages create a cluster so that if you knew either 5 of the ones I said, you would actually know the others. I haven't cheated with the numbers. I rounded out at the science base. It would be nice beyond that to know something quite weird outside it, just to have an experience. Pick one of the functional languages, for instance. That's good to keep your head spinning a bit when it needs to. I don't have any favorites in that field. There's enough of them. And I don't know, if you're interested in high performance numerical computation, you have to look at one of the languages there. But for most people, that's just esoteric.
All right. So according to Björn Strastrup, the list he gave were actually the list of programming languages that are actually effective. So he said, before I give the list, I just want to be honest that the list is because these are the most effective languages. Then he said C++, of course, is the first one. The second one he gave was Java. Then the third one he gave was Python. And he said, if you know these, they are actually going to help you know the others, because they all work together. Once you understand these 3 languages, you understand C automatically, you understand C# automatically, you understand JavaScript and Ruby automatically. And so these are the most powerful languages to learn. And he said, you can't call yourself a professional if all you know is one language. So keep that in mind. You can't call yourself a professional programmer if all you know is one language. So if you want to be a programmer, you need to learn at least 3 languages, and that will make you a fully qualified programmer, and you'll be able to work anywhere. So thank you very much for indulging me in these short clips. Let me share my screen again, and let's see what is next. So all right, so let's just get onto. Okay, I have one more slide. Let me just show it, and then we would write some code for today. So today is just the introduction to C++. From tomorrow, we are going to delve into a lot of coding. So from tomorrow, our slides will go down a little bit and we'll do more of coding. All right, so C++ was designed to be a successor to the C programming language. It was developed by Behan Strastrup at Bell Labs over a period of time starting in 1979. Since C++ is an attempt to add object-oriented features plus other improvements to C, earlier it was called C with objects. As the language developed, Strastrup named it C++ in 1983. So in 1983, it became C++, and the name suggests that C has been incremented. So you have to remember that this plus plus is an increment operator. So once we start doing some calculations with C++, you will know that anytime we use plus plus, it means we are incrementing a value. So C++ means C incremented. C++ is not a new language, yet one that is popularly adopted and still being improved upon. The latest version of C++ released in 2020 is called C++ 20. So that's the latest version of C++. So that is it. So let me share my second screen and let's practice some simple coding. All right. Wonderful. So I believe you've heard from the man who made C++. This man didn't develop a software. He actually created a language. So he's an advanced software developer, but we are not talking about someone who just made a software. We are talking about someone who created a language. All right. By the end of week 3, we are going to develop this app. You see this app here? This is the app the morning class just developed. So you can see here, quick math. By end of week 3, we are going to have this app. So you are going to create apps for computers. So I'm not going to open it. By the time you finish, you also have yours. All right, so let me open to Visual Studio Code and we will just get into it. All right. So this is Visual Studio Code. Today is just a welcoming class to C++. So we just do something simple. And from tomorrow, we'll do a lot of coding. All right, so create a new file. And you select a language. Of course, the language is C++. That's what we are going to use. And remember, you have to include your IO stream. Tomorrow, we'll talk about this IO stream, and you'll be amazed. You'll learn that this IO stream is actually a file. This IO stream is a file. I'll open it tomorrow for you to see, and you'll see that it is actually a file. All right. Over here, I'm not going to include the namespace std. Yesterday, we talked about namespaces. Tomorrow, I'll talk more about namespaces. So we know that instead of including or adding the line using namespace std, you can simply use std : : So we talked about this yesterday. So you can do this and type cout and say, welcome to the C++ coding bootcamp. All right. All right, so this is a valid line. Now this endl is wrong. We need to add std : over here. All right. Now, from tomorrow, we are going to learn about comments. And to write a comment, you need to bring this / two of them, and you type what you want to do. So here, I'm going to declare some variables. Now, anytime you see someone using C++ and he starts with this is not code. This is just a comment or an instruction to the reader, not an. So the compiler will actually ignore this. So anytime you are writing code, it is advisable to tell us or tell yourself what you are trying to do, because your code can become complex that you can actually forget why you wrote certain lines of code. So I want to declare some variables here, and I'm declaring a variable called string. And this string, I will create a variable name as name. We'll be learning about variables, and you'll know that we create variables to store. For this string to work, I need to assign it to the std namespace. If not, it's not going to work. But then this is the name of my variable. I want to declare another variable here. And this variable, I'm going to call it int. And I'll call it int number. Then I'll create another variable. I'll call it float. And call this float, let's say, salary. So in C++, there are certain key things that you need to keep in mind and you need to understand. These key things, if you don't know them, there's no way you can write code. A string variable is very important because without it, you cannot store any string of text in memory. This is an int variable. It's very important. We have float variable. We also have double variable. Double variable, double. So here we have double variable. We have a char variable. All of these, we'll talk about them. We also have a bool variable for Boolean values. All of these, we will be talking about them so that you understand programming. We also have what we call if-else statements. We can just call them if statements. And these if-else statements, what they do is that they help you to know or to test conditions. So I can say that if, into brackets, salary is less than 2,000. Okay, if salary is less than 2,000, what should happen? Do something. So I'll put the instruction here. Then I'll come here and say else do this. All right, so this is what we call if-else statements, and this is powerful. If you don't learn if-else, you can't do programming at all. Because when you write a program, your users will do what they feel like they want to do. You know, we don't write software to control people. We allow people to use software. So they want to use your software to do what they want to do. If you get a software like VLC, do you want VLC to force you to watch a particular movie? No, you want to do what you want to do with it. If you get Microsoft Word, you want to do what you want to do. And so we don't know what the user wants to do. And so we do a lot of if. Sometimes we just write if so that the code we put in these curly brackets, take notice of them. The code we put in the curly brackets will be the instructions. Here we put the condition, or the condition here. So once this condition is met, the code here will run. If this condition is not met, everything here will be ignored. The compiler will not even look at it. The compiler will just throw it somewhere. So the code here in this curly brackets are going to run when this condition is met. Sometimes we just do if. Other times we do, watch this, we do else if with a different condition. So let's say else if salary is greater than 2,000, do this. Then do this. Then sometimes we also do else do this new thing. So you can write if, else if, else. Now you can't do else if there's no if. So if says there is a condition. Else if means, okay, what if the condition is different? So else if the condition is different. And else means any other thing apart from the condition. That means if the condition is not met, any other thing should work. So keep this in mind. In C++, you also need to learn about loops. We'll be talking about loops a lot. Loops. Without loops, we can't do anything. So we'll be learning about what we call for loops. We'll be learning about while loops. We'll be learning about do while loops. These are powerful. So we'll be getting into all these things. And once you understand variables, C out, C in, endl, if statements, loops, let me tell you, you're already an intermediate programmer in C++. Then we'll go ahead and learn about arrays. Wow, once you learn about arrays, you are really getting stronger. We'll learn about what we call functions. Whoa, by the time you learn functions, then you are becoming a boss already. I'm going to put classes at the end because when we talk about classes, we are talking about object-oriented programming. So I'm going to put classes at the bottom. If you learn about pointers, if you learn about structures or what we call struct, if you learn about classes, what we have here, once you understand these things, you are already seriously into programming. So God willing, from tomorrow, we will delve into namespaces and headers. So we'll learn about headers and namespaces. And from there, we will create, tomorrow we are going to create a simple supermarket application for a supermarket to use. Yesterday, we created a game. You can play the game over and over. Tomorrow, we are going to create a supermarket app, just a simple one. Then on Sunday next week, we are actually starting our real project. I told you that the morning class, they finished their projects, and this is the app they created. This is the app they created. I told you that at the end of each module, we are going to create an app. And the first module will end on week 3. So the morning class, they have completed their week 3. Tomorrow is the examination for module 1. Then next week, next Sunday, they are starting their module 2. So for the evening class, we are now taking you through the basics and preparing you to do programming. And by the time we get to week 3, you are going to understand a whole lot that will make you comfortable to understand a lot of code and be able to write some basic programs. So I'm not going to take much of your time today. I wanted to talk about the STDs and namespaces, but then that is for tomorrow. And yesterday, I already explained the STDs to you. So I think we will just wrap up and continue tomorrow. But then don't forget about ifs. Don't forget about loops. And there are 3 loops. We have while loop, for loop, and do while. Don't forget about variables. Oh my goodness. If you forget about variables, you are in trouble. Now, you can see that all these variables, they were all recognized immediately. But the string variable was not recognized because the string variable is not really part of the family of variable data types like the others. And so with a string variable, it only works when the STD is attached to it. Now, we are not attaching STD because or sometimes we don't attach STD because it works automatically. That's why you don't see it. But when it comes to the string, you need to attach the STD. String belongs to the STD namespace. Let me save this and call this, let me just call this C++.cpp. Now, after saving this, you see that the string is going to be colored. And over here, if I come here and I say that cout number dot, you see that nothing shows because this number is an int variable. That's what we declared here. And it is something that is an ordinary variable. But this name is a string variable. So when I come here and I say name dot, whoa, you see that several properties are already popping up. Because when it comes to string variables, they are actually functions that hold several properties. So as we advance, you'll learn that string is a little bit different from the other data types. But then when we start learning about variables, you are going to learn about string, you are going to learn about int, double, float, char, and bool. So thank you very much for joining us. I don't know if Mr. Peddy is around to give the announcement. And I will end here and we'll continue tomorrow. All right. Mr. Dai, do we have any announcements?
Hello. Hello. Yeah, good
Yes,
evening.
hello, we can hear you.
The announcement is we thank you all for joining the class this evening, and we are hoping and looking forward to see you tomorrow. Please let us try and join 5 minutes to time so that we can start on time and then we keep to our time. And then also, the free session will end tomorrow, God willing. And from next week, Sunday, we'll start the paying session. You have to pay before you join the class. So this is how it's going to be like. If you are paying for the rest of the 13 weeks, if you are paying in full, you pay 100 Ghana cedis instead of 130 Ghana cedis. If you want to pay weekly, you pay 10 cedis a week. And then from next week, the recordings will be at a fee. If you want the recording for a session, it's 5 Ghana cedis. If you want the recording for the 6 days, it's going to be 20 Ghana cedis. So please, let's also continue to be ambassadors of the program so that we share the good news that we are enjoying. The payment details will be shared soon. And after payment, we'll move those who have paid to the Telegram page where we'll be sharing other resources. Thank you all. And Prof, if you have any last message before we sign off.
All right, so thank you all in this bootcamp. We are more than serious. So prepare and make a payment. And we've already given discounts to those who make a full payment because paying 10 cedis is like, it's a waste of time to some of you honorable. So we are giving you 30 cedis discount. So just pay 100 cedis to cover the whole of the 14 weeks. And I think this is a really, really good deal. The 100 cedis we are taking is just to keep the lights on and to fix our technical issues. It's not really any profit for us, considering the number we have. So just make your 100 cedis payment, and next week we are starting our apps and we are learning a whole lot. We are delving into details. But tomorrow we will look at header files, namespaces, and all that. So thank you once again. Have a blessed evening, and I will see you tomorrow. Bye-bye.
Bye. Good night, everyone.